Welcome to Study Loop.
Let's evaluate the given integral. The first thing to observe here is that the numerator has larger degree than the denominator. So we should do polynomial division to simplify before we even consider partial fractions. So let's do the division here. X to the fourth divided by x squared. That's just x squared. Let's go ahead and multiply that out. Then we subtract. And we're left over with x plus 2 because we have cancellation here. So this tells us that we can rewrite the integral as x plus 2, x squared, this is the quotient. And then we have our remainder, x plus 2, over the original denominator, x squared plus 9. So this is a simpler looking integral than the original. There's really no need for partial fractions here because this term over here already is a partial fraction. We have a quadratic in the denominator that does not factor, and then you have your ax plus b in the numerator. So really, we're ready to integrate. Let's break this into 3 integrals. And then we could split up this fraction. This is just x over x squared plus 9 plus 2 over x squared plus 9. So let's go ahead and integrate each of those. And then for the last one, let's go ahead and pull out that 2. And now we have 3 integrals. So the first one, just use the power rule. We know that's just x cubed over 3. Don't worry about the c for right now. We'll add that in later. Now for the second integral, we should do a u sub here. Let's take u to be x squared plus 9. Then du over 2 equals x dx. So this is just 1/2 integral 1 over u du, which is 1/2 natural log absolute value u equals 1/2 natural log, and then replace u with x squared plus 9, and you could drop the absolute value if you want because x squared plus 9 is positive. So that's a 2 up there in the exponent. You rewrite this. And then we have one more integral to go. We have this integral and then times 2. For this integral here, we should go ahead and do a trig sub. We could take x to be 3 tan theta. So that dx is 3 secant squared theta, d theta. And then this integral just becomes 2. Then on top, we have 3 secant squared. On the denominator, we'll have 9 tan squared theta plus 9. Let me go ahead and factor out that 9. And then we use fact here that tan squared plus 1 is just secant squared. So we could cancel the secant squared terms. Then we'll have 2 over 3 integral. The tangents cancel, or the secants cancel. We just have d theta. That's just 2 over 3 theta. And then theta can be solved by the original trig sub, by solving for theta. Divide both sides by 3. And then take the arctan of each side. And then that'll cancel the tangent on the left. And then on the right-hand side, you have tan inverse x over 3. So we've evaluated all 3 integrals. Now we just add our answers together. So we'll have integral equals here. This was the first term. This was the second term. And here was the third term, 2 over 3. And then we have tan inverse x over 3. Do not forget the constant c of integration. Let's go to the next page and write this answer. First integral, we had x cubed over 3. Then for the next one, 1/2 natural log x squared plus 9. And then for the last one, the trig substitution, we had 2 over 3 theta, and that became tan inverse of x over 3. And then finally, we can add our constant of integration, and that'll be our answer.